Okay, good afternoon. So today we're looking at probability, chapter 12, and this is on page 396. Okay, since you guys didn't come this morning for your lesson, okay, not holding any grudges. Yes. I was crying here and I was here all alone and stuff like that. So, but you guys had better things to do, no? You had to make money for a matric ball. For what? I don't know. Right, so you guys can now go through the revision on page 396 dealing with grade 8, 9 and 10 probability and terminologies and all of those things. Okay? Definition, explanation and examples there. This is all on page 396. Before you go do your homework on probability this afternoon, please read through it. Okay? It carries on to page 397. Okay? Then we are given the additional law for probability. For mutually exclusive events, okay, I'm going to copy this here, put this on the. And it's on page 397. See that example. We are told the addition law for probability. Mutually exclusive events. Now, mutually exclusive events we've dealt with before. Okay? Who can remember what mutually exclusive events mean? Yes, you're making. What does that mean? They don't intersect, they don't touch. Okay, not touch but overlap. Okay, so for mutually exclusive events, it means to say that there's no elements in set A that is evident in set B. Okay, so in other words, if you got this here, this is what mutually exclusive events looks like. Okay, there's no overlap here. Can you see that? They are apart. Okay, make it further apart. So if that is A and B, they are what we call mutually exclusive. Okay, they are mutually exclusive, which means to say there's no element that belongs to set A and set B at the same time. Right, you guys understand that? So let's see what they say here further. So mutually exclusive events are events that cannot take place at the same time. If two events, A and B, are mutually exclusive, then the addition law is the probability of A or the probability of B is equal to the probability of A plus B. So we just add the probabilities of the two, will give me the probability of the total sets. Okay? Make sense, people? So example 1. And as I have indicated, this is on page 397. Page 397. A bag contains 5 red discs, 3 blue discs. So it's 5 red, 3 blue, 2 yellow. Okay. A disc is drawn at random from the bag. So how many discs are there in the bag in total? There are 10 discs. Not so. The question says calculate the probability that disc is drawn, in the first case, a red disc. It's the probability of a red, write that answer in. Then you answer B and C for me as well. Okay, so how many read this guy then? 5 out of 10, which is 1 out of 10. If you're looking at probability, what is our probability? Probability is a calculation. The formula for probability is the number of favorable outcomes. Like in this case, what do you want, what you're looking for, which is a red, over number of possible outcomes. In this case, is 10 because there are 10 discs in the bag. Make sense, people? So let's look at B. B says a blue disc, the probability of it, the disc being blue. How many blue discs are there? 3, so 3 out of 10. C. See this? We always cancel, no? We simplify as far as possible. C. In C, a red or blue disc. Red or blue. So that's going to be the probability of red plus the probability of blue, which is simply 1 out of 2 plus 3 out of 10, which is, it's 5, 8 over 10, which is 4 over. You all agree with that, people? Otherwise, I could have counted red is 5 and blue is 3. Together it makes 8 out of 10. Could have done that as well, which is 4 over 5. No? You all agree with that? You all understand? Any confusion? What if the question was, what is the probability of not drawing a blue? Of not drawing a blue. Why 7? Because they are 5 and 2 not blues. So it will be 7 out of 10. Or also in grade 10, you guys were exposed to the complementary rule. Okay, which was the probability of B plus the probability of not B will always be 1. Okay, were you guys exposed to that rule? Okay, everybody's going to say no until the bell rings, then everybody understands. No? But okay, if you didn't know that, write this down. That is the complementary rule. Okay, the probability of A plus the probability of not A will always be 1. Okay, if I drew a Venn diagram to illustrate this information here, this is what the Venn diagram will look like. If I have a sample space, this is subset B, not so? And everything outside, that is the probability of B, everything outside will be not part of set B. Can you see that, people? So if this is in probability, it will be 1B. Not so your sample space will always add up to 1, or if it's percentage, it's going to be 100%. Not so. So here the probability of set B, subset B, plus the probability of no B, or the elements that doesn't belong to B, which is this on the outside. This will always add up to the total, which in this case is 1. You guys understand? Huh? Yes. Okay. So if I apply the complementary rule here, the probability of not B would have been 1 minus the probability of B. So it's going to be 1 minus. What's the probability of B? 3 out of 10, which also gives us 7 out of 10. So it's either that or I could have applied it as we did there. Do you guys understand? Okay. I'm glad you guys understand. As I said in the powdings. Right, so for homework, I want you guys to do exercise 12.1, and that is on page 399. Then I want you guys to read through page 399, calculating probabilities using the Venn diagrams. And then you read through up until page 400. So tomorrow we're going to tackle Venn diagrams. Okay. People, enjoy the rest of your day. Oh yes, an example too I'll do tomorrow as well. Enjoy the rest of your day. Good afternoon, class.